Today we're doing 6-3 binomial radical expressions. Your learning goal is that you will be able to add and subtract radical expressions. And in order to add or subtract radical expressions, we have to have like radicals that have the same index and radicand. So what I mean by that is the index has to be the same, and the radicand has to be the same. That's the number or term under your radical. So both of these, they have to be the same in order to add or subtract. Okay, so let's try one. Okay, so you always check your index and your radicand. If they are the same, then you only add or subtract the terms in front of them, which is a 3 and a 2. So 3 minus 2 is 1 square root of 5x. And then you're done. So let's try another one. Okay, if you notice, my terms are not the same, my indexes aren't the same, and my radicands aren't the same. So in that case, you'll just write not possible. And we can look at another one. Okay, so my index and my radicands are the same. So since they are, you can go ahead, I underlined the wrong term. And add, so that's 7x, xy, square root of xy. So all you're doing basically is combining like terms. Okay, now sometimes you have to simplify before you can add or subtract. So I'm going to break down each one that I can. So I know 12 is 2 and 6, and then 2 and 3. So that means my 2 comes out, because I'm doing groups of 2 since it's square root. And my 3 stays under. 75, I know is 25 and 3, and then 5 and 5. So my 5 comes out, because it's a group of 2, and the 3 stays under. And then if you notice, this one is already simplified as far as possible. So I have 2 plus 5, 7 minus 1, so that's 6, radical 3. Okay? So let's try another one. Now we're doing cubes, so we need groups of 3. So 250 know I can use, it doesn't matter how you break it down. 25 and 10, 5 and 5, 5 and 2. So there's my group of 3. So the 5 comes out, but the 2 stays under. Then I break down 54. I got 9 and 6, 3 and 3. 6 is 3 and 2. So there's my group of 3. So the 3 comes out, the 2 is left over. And then 16. I have 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. Here's my group of 3. So my 2 comes out, but I have an extra 2 left over. So now that they're all the same, you combine like terms. So I have 5 plus 3 is 8, minus 2 is 6. So it'll be 6 cube root of 2. So once you get here, you can combine like terms. And then we're done. Okay, so now we're multiplying. We have a binomial you want to FOIL. So 4 times 5, that's 20, plus 16 radical 2, plus 10 radical 2, plus 8 times square root of 4. Well, we know the square root of 4 is 2, so 8 times 2 is 16. Combine these together, we get 26 radical 2. And combining like terms further, we get 36 plus 26 radical 2. Okay? Then we can try another one. These two terms, or two binomials, are called conjugates. And conjugates are fun because when you FOIL them out, the inner and the outer terms are going to cancel. So this cancels. This becomes 7. 25 minus 7 is 18. So those are called conjugates. Okay, so if you remember, we can't have a square root in the denominator. So when we have a binomial, you want to multiply by what we call the conjugate, which would be square root of 5 plus square root of 2. Whatever you do to the bottom, you have to do to the top. So I'm going to multiply those. So on the bottom, I'm going to get 5 minus 2, because when you do the outer and the inner, they're going to cancel. And then on the top, I'm going to get 3 square root of 10 plus 3 square root of 4. And square root of 4 is 2, so 2 times 3 is 6. All over 3. And dividing both of those terms by 3, this is your final answer. And we'll try another one. Okay, so in order to rationalize this denominator, we would need 3 2's, and right now we only have 1. So we need 2 more 2's, same in the top. That way we can get a 2 cubed on the bottom. And then on the top, I'm just going to distribute. And I'll get 4 cube root of 4 plus cube root of 2 cubed. And then simplifying this, I'm going to get 4 cube root of 4 plus 2 over 2, because the 3's will cancel. So dividing each one, I'm going to get 2 cube root of 4 plus 1, or you can write it the other way.